Hey there, in today's video, I'll be giving a demo on how we built a non-custodial payment gateway on the Moonbeam network, which is an EVM-compatible parachain within the Polkadot ecosystem. A non-custodial payment gateway allows for merchants to receive any ERC20 token in a secure manner. One thing to note about the Moonbeam network is that the native ERC20 tokens on Moonbeam are represented as XC20s. XC20 tokens follow the ERC20 standard, but also support XCM messaging, allowing them to move seemingly across other parachains. Now, let's take a look into the structure of this flow. First, the user will have to approve the amount of tokens to be transferred out of their balance to the smart contract by calling the approve function on the XC20 contract. Then, the user will invoke the process payment function on the payment processor smart contract. We'll later dive into more detail on how this works. And then finally, we have an indexer that will be listening for payment complete events, then serve those events back to the front end via GraphQL. Now, let's dive into how the payment processor code works. In order for a payment to be valid, the payment payload must first be signed by an authorized signer. The payment payload includes the address of the recipient, the sender, and how much is to be transferred. An authorized signer can be a key managed by your server through a method like a multisig or any other mechanism. This way, in your off-chain business logic, you can verify that the receiver and sender address do not belong to fraudulent addresses. By performing a query to a service like chain analysis, this allows your service to be AML compliant. After your business logic gives the sign-off to the payload, the message will be returned to the client alongside the signature of the authorizer. Then, when the user calls process payment function, passing the signature and the payment payload, the process payment function will reconstruct the message hash and verify it was indeed the authorizer who signed this message. To show you a demo of how this works, let's navigate to Moonbase Alpha testnet faucet, grab some dev tokens. Afterwards, we need to go to a Moonbase DEX to swap our XC unit tokens. For the sake of the demo, we will be using the XC unit tokens as the medium of transfer. After we swap some dev tokens for XCUnit, let's head on over to our code by navigating to the Moonbase-SE directory. In this project, we are going to use Forge to compile our Solidity contracts. So let's go ahead and run Forge build, and then run this deploy script to deploy the contract. You want to put in a private key of the approver who will give sign-off the payment payloads, and then also the RPC of the Moonbase Alpha network. After you deploy your contract, you're going to need to copy that address into two places. The first place is the .env under the indexer project. This will allow your indexer to be able to listen to events coming from that contract address. In addition, we also want to specify the block start number to be the latest block so that we don't start indexing from the beginning of the chain. So now we'll navigate to the Moonbase Alpha block scanner, grab the latest block, and then fill in the parameter. Then with the same contract address, we'll go into the root of the Moonbeam directory and pass it into this .env. This simulates the client side for when the user calls the process payment function. After this is all set up, let's start the indexer. So let's navigate back to the Moonbeam indexer directory, run docker compose up, and then start up the client-side listener that will query for new payment process events. Now that's all done, let's run this following script, which will simulate the client side for the user, approving the transfer of the tokens, signing the payment payload, and then submitting the following signature and signed payload to the contract to finalize the payment. So after we call this function, you should see that the approval will first come, and then once we submitted the transaction, we should be able to see from our listener that the event was successful, and we can find that the payment ID from the event matches the payment ID that we used to submit the transaction. If you want to play with the code yourself, the links to the project will be under the description.